Alrighty, hello everybody, and welcome back to the channel. Thank you all for your support. I really do appreciate it. What are we doing today? Today I'm going to go over the astronomy sensor. So what eventually I want to do with this rocket is I'm going to replace this cone, and I'm going to have like a separate lander. So when it goes to the moon, the lander will detach, and it'll be its own smaller vehicle that we can then safely get down to the surface of the moon, and then if the rocket wants to crash, it can crash, do whatever it's going to do. So eventually this cone will be replaced, probably in the next couple of videos here, we'll see. But today I wanted to go over this thing right here, the astronomy sensor. Alright, so the astronomy sensor gives us data. We can actually delete these. It gives us data, and we want to be able to read that data, and we want to be able to interpret it in some way. So if I get us a monitor, because we want to be able to see, let's see, is it going to be a 3x3, or is it going to be, let's go with a 2x3 monitor for now. This is what I did in the shuttle. Okay, and now what I want to do is, I want to take electricity, and then when we sit in this seat, it's going to turn on the monitor. Alright, so the other thing we're going to need is another blank microcontroller. And this is probably going to get it will eventually get a lot larger. But for now we're just going to leave it like that. Alright? So, we need a couple of things inside this blank microcontroller. We need our composite in, which is going to be in from Astro sensor. Alright? Without that. And then, what else do we need? We need we need a video out, which is, this is going to go out to monitor. That's all we need for now, because everything we're going to read from the astronomy sensor. Alright, so let's update that, and then let's connect our logic, so that way when I go to test it, I always forget to do this part. Perfect. Okay, so now we're going to go back into here, into the microcontroller. Okay. Now we need what's called a Lua block. This is where we're going to write the code, which is going to handle all of our inputs, and the video is going to go out. Okay, and now what we need to do is we need to take some numbers from here, and we need to pass it. So we can just do that if we want. I can connect it directly to the Lua script. So I know what I was saying. No, let's just do that for now. We're just going to read this directly from there. Alright, and we'll just see how that works for now. We'll see how that works for now. Alright, so we'll go into the Lua script. We're going to delete all this code. We now have a blank script. Alright? So there's going to be two sections to our script. There's going to be the onTick function, which means every logic tick it's going to read our functions. And then we're going to have our onDraw section, which means after it reads the data, it's then going to draw it so we can see what we're doing. So the first thing we want to do is we want to say function on, and then I think it has to be capital letters like that. onTick. All right. And then of course, it's funny. I guess I didn't have to worry about that. I put the end in at the end. Okay. So I'll just talking about Lua here. So the Lua script in Stormworks interprets two things: a Boolean, which is a true signal or a false signal, and the number. It can take a number, it can do some math, it can change it, and it can output that number. Whatever. We can add two numbers together, we can subtract, we can do whatever we want, right? So in this case, we aren't going to be using the getBool function, which is basically an on-off. So if I activate a toggle button, it's sending a true signal. If I deactivate the toggle button, it doesn't send a true signal. That signal becomes false, right? So you have a true and your false. Very powerful, especially if you need to read. Like for example, when I was marking our rotation on the screen, and I wanted to say if, right, mark X true, mark Y true, mark Z true, right? We had to do those couple of things. So, getting that out of the way. So what we're going to do is we need our distance, we need our rotation, and we need our angular velocity. Now, why do we need our angular velocity? We don't, because it only works if you apply velocity to the angle. It's kind of stupid. I was hoping that they would give us our actual velocity, which is distance traveled divided by time. So I'm going to have to do that here in the Lua script and see if that works. Okay, so the first thing we're going to do is we're going to say x distance, and then we need our y distance, and we need our z distance. All right. Then we need our Euler, E-U-L, what did I spell it there? R-O-T-X. That's our Euler rotation, U-L-R-O-T-Y, and U-L-R-O-T-Z. That's our rotating X, Y, and Z. And then, so I'm going to change it. It gives you the angular velocity from the sensor, but like I say, it only gives you the velocity if you're applying velocity on that. So, for example, if you thrust in direction Z, it'll tell you your velocity while you're thrusting. But as soon as you stop thrusting, the velocity goes to 0, even though you're still moving in that direction, which to me is stupid, and they really need to change that. I'm just saying that right now. So we're going to say velocity X, velocity Y, and velocity Z. Now these we have to handle on our own. All right. So distance is input get number. So let's see, where do I get these numbers from? We'll update that. If we look at our composite and we hover over the astronomy sensor, it tells you your outputs, right? X position in meters, Y position in meters, Z position in meters, and then it gives you your Euler rotation, X, Y, Z, which is 4, 5, and 6. And then it gives you your angular velocity, which is 7, 8, and 9, and then it gives you your local tilt. Now I'm not going to be using the tilt, and I'm not going to be using the angular velocity for this one because for me it's absolutely useless, right? They need to handle it in a different way. All right, so we can do this. We want to say input, make sure we spell it right. Input dot get, and we need to capitalize that. Get bool has to be like that, and we're going to say number 1. All right, and I'm going to copy this, and we're going to do that, and then what I'm going to do is I'm going to copy this, and we're just going to put it like that there, so I don't have to write it every single time. So this is going to be number 2, and this is going to be number 3, and this is basically 4, 5, and 6. All right, and then our velocity is going to be we need to calculate our distance, and then we need to divide that by the time it takes us to travel that distance. So I think what I want to do is I'm not going to worry about that. Or do I want to worry about that? Let me see. So how I did it in the shuttle is I handled this outside of the Lua script, and then I just printed the number in. I just brought the number into the script. And basically what I did is because this has to be an on-off. So what we need to do is we need to say input, yeah, that's how it's going to be. Input get bool. All right, and then, oh, no, this has to change. This isn't going to be get bool, this is going to be get number. My apologies. These are numbers. So we wanted to read as a number and not as an on-off, right? Because these are numbers that we're getting right now. Sorry about that. Now, I mean, this is just real basic. There's more advanced ways that you can design these scripts. Like I said, this is basic. Now, this one here, these are going to be on-offs, right? So, so now what I have to do, because if I say get bool 1, 2, and 3, it's going to be reading numbers. It's going to be reading input 1, 2, and 3 from here, from the astronomy sensor. So now what I need to do is instead of bringing the astronomy sensor directly into the Lua script. What I need to do is I need to separate. No, I need to separate the composite. Right? So we are reading the first 6 channels. Oh wait, no, I did that wrong. We need to write 6 channels. 2, 3, 4, 5, and 6. Right? Let's see here. 2, 3, 4, 5, and 6. And then this way we can control what gets read here in the Lua script without confusing it. Then we need to write that number back to a composite signal. Right, channel 1, 2, 3, 4, 5, and 6. And that's basically it. Then what I want to do is we need our on-off, right, for our velocity. So what we're going to do is I'm going to make a panel, a composite panel. All right, we'll take a composite panel here, and what we're going to do is we're going to turn these into flip switches. And this one's going to be a flip switch. All right, and then this one here is just going to be, we'll set that to none. This will be channel 3, channel 2, channel 1, and then we'll say velocity X, velocity Y, and velocity Z. All right. So now what we need to do is we need to go back into our microcontroller, and we need to add an additional composite channel. So not the composite, this is going to be in from velocity. Oops, would help if I spelled from properly. So we'll say in from velocity, all right. And then that is going to be, so now we have another composite input. So now what we need to do is we need to take this, and we need to read the on-off, channel 1, channel 2, channel 3, and then we need to write those channels. All right, and then we can do that. We can link our composite through the additional composite, and then that way we're not getting any of the on-off values from the astronomy sensor. I don't know if it probably does, but unless it only gives numbers, I'm not sure. But you have to be careful because we're going to go over the RCS thruster as well, and you'll need to separate it like this because there's some numbers that you can get. Also, there's like the radar. I'll have to go through radar again, separate it, and do that same thing. So I'll cover all that again. I want to do like a comprehensive sort of Lua thing. Okay, so channel 1, this is going to be channel 2, and this is going to be channel 3. Perfect. So we're going to go back into our Lua script. Get bool 1, get bool 2, get bool 3. Now, additionally, what I need to do is I need to set up a timer. And how did I do this? So this needs to be a, let's see, I might actually need 3 timers here. 2 and 3. So we're gonna kind of doing this on the fly. So I apologize if I take 2 steps forward and then 1 step back. So this is going to be our on signal, our on signal, our on signal. So we need a constant on signal. Then what we need to do is, because what that does, then we need a constant number. All right, and this is going to be like our seconds basically. And I know I used 3 seconds on the last one. I suppose I could turn it to 1 second. I just thought it would be easier if I used more than 1 second. So I just used it at 3 seconds. So it's going to wait 3 seconds, and then what it's going to do, it's going to say, okay, now I'm complete. I want to send out another signal. All right. So what we need is our, we need to read our distance, which is 1, 2, and 3. Channel 1, channel 2, channel 3. All right. So what it's going to do is it's going to take this distance and it's going to divide 2, 3. So we'll say 1, A, and it's going to divide that by the amount of time it takes to travel. Then it's going to give us our output. It's going to give us that number, whatever that final number is. So, I suppose in this case, that's not gonna work. That's not gonna work. Because we have to read this number. Yeah. I've only done this once, so all right. So what we actually need to do is we need to clamp. Right? We need to clamp. We need to clamp this value. Right? So is it clamp or hold on. Let me just see what I did. Let me save that as well because I'm gonna load the shuttle. Let me just see what I did here on the shuttle before I get too involved in all this stuff. And then we'll build it and I'll explain it as we build it here. Let me just take a look at the shuttle and see how I did that. It was kind of complicated how I had to do it. All right, so this one here, and this microcontroller here, and this was our what was this one here? Let me see, is that right? This one way over here. This is our velocity. Yeah, our velocity here. So what I had to do was what's this one here? This is constant number, so this is what we're dividing. And then we're taking that, right? We're subtracting it. And I'm actually using the memory registers, and I had to use a toggle, pulse toggle. Okay, perfect. I think I know what I need to do now. Okay, that was really quick. So now we're gonna build it, and we'll go over it really slowly. Okay. So the timer. How does it work? Well, it needs a constant on signal for the timer to be on. It needs a constant on signal going into the timer, and that's what this is going to be, our constant on signal. Then it's the output can't be a constant on signal, because to use the memory register, we have to use a pulse signal in order for this to save. If it has a constant on signal, it's going to be constantly reading that number, and it's going to be confusing. So, what do we use the memory register for? Well, we need to read these values. We need to read the current X, Y, and Z. All right, and then we need a push to toggle. What's this one here? Toggle signal. Oh, that's an internal signal. On-off switch that is toggled every time a new signal is sent. Oh, that's cool. So we're just gonna keep this really simple here, okay? So number 1, number 2, number 3, and then this is gonna be off to on, right? And then this is gonna be our set, and set. And I suppose I don't think this one we have to reset, okay? So we turn the button on. It starts the timer. Oh, we need more memory. We need 3 more of these. 1, 2, and 3. It starts the timer, and then it's going to read that number after 3 seconds. So then what we need to do is we need to take this number here, alrighty, it's going to be a little confusing. And we also need to take 3 more toggles. Right, 1, 2, 3, and we need to go like that. 2 and 3, and we need to say, okay, read our current. I should sort this out, right? So what we're doing here is we're saying, okay, read our current X, Y, and Z, and then after 3 seconds, read our X, Y, and Z again, right? Then what we're going to do is we are going to subtract those numbers from each other. So we're going to have our current X, Y, and Z. How does that work? A minus B. So this one here, we need to take our larger distance and we need to subtract our smaller distance. And that is going to give us our velocity. That should be right. All right. So let me go over this here. So we have our input from our panel. We have our 3 buttons, 1, 2, and 3. Okay. Those are going to be constant on buttons. We want to use the memory register to save our current X, Y, and Z. So we need to turn those into push buttons. So it'll say on, and it'll read that. Then what we're doing is we're saying, okay, at the same time, start this timer. And after 3 seconds, the timer is going to throw a signal out. We need to convert that signal from a constant on signal to an on-off signal, because otherwise it'll pass this constant on signal through the timer, which we don't want, and we're not going to be able to get an accurate velocity. We're gonna be testing this to make sure. I'm gonna do a test launch, so we don't need that anymore. What we actually need to do is we need to expand this here, and we need to give it 9 channels. And then channel 7 is going to be X, channel 8 is going to be Y, and channel 9 is going to be Z. And then that can go directly into the Lua block. All right? So this will be 7, 8, and 9. And we have to change that from get bool to get number. All right? Perfect. So that handles our input. So every logic tick, it's going to read this. Now what we want to do is we could do our. Now we want to do a function on draw. All right. And I suppose I could check for errors, but it's going to be. We need an end. Where is it here? We need an end here for that. Whoops. Is that going to work? And then, I don't know if I need to end it here. I think I need to end it here, actually. I think that would, 17. Oh, I need 2. I can end it twice. I can do that. There we go. I can either put an end here for the on tick, which I probably should, and that way it separates the 2 functions. Like that, and then we have that. This is this function, and then this is this function. Okay. So now what we want to do, now what I want to do is, it's not going to draw anything. So what do I want to draw? Well, I would like to draw our 3 angles, our X, Y, and Z angle. And then what I also want to do is below that, I would like to print our velocity and all that sort of stuff. So let's just test the velocity and see if that's going to work. So what we need to do is we need to draw a text box. So we're going to say screen dot draw text box. And now if you go into help and you want to say, well, what's the code for the drawing a text box? It's right here. And then it can give you the X and the Y, the width and the height, and then the text. And then you can have this. You can align it if you want. All right, so that's pretty much what we're going to do. So our X is going to be 1. So we're in 1. And we're going to be down 1. And then we're going to say... and then our width, let's make it 30. And then our height is going to be 6. And I think that's the height of the text. Here, let me look at this here. We'll say, yeah, width and the height. Now, when you draw text, it says each character is 4 pixels wide and 5 pixels tall. So if you wanted to have a 1 pixel gap on top of the text and below the text, you probably want to make that 7. But then I don't know if where the text prints, the text might actually print on the bottom. So I just do 6, and then that way there's a 1 pixel gap on top. All right. Then we're going to say to print a number, we can't just say velocity. Like I can't just say vel x like that. It's going to give me an error. It's going to say, well, I need to translate that into a number. So what we need to do is we need to say string dot format. All right, and then we want to say put it into quotation marks. Oh, I gotta change my keyboard. I really hate Canada sometimes. Okay, in the quotation marks we want to say percent. And then we're going to go to F. Now this number here is how far past the decimal point you want to go. If I set that to 0, then what it's going to do is it's going to have 0 decimal points. But I want to say 2 decimal points in this case, just for the velocity. I guess I don't necessarily need to have 2 decimal points, but we're going to set it to 2 decimal points. And that's going to give us our velocity, right? And now the velocity is going to be, and then we can say VEL X, just like that. All right. And then our alignment is going to be 1 and 0, right? Our height and width. Now this, our height alignment and our vertical alignment. So it says draw text within the rectangle. Text alignment can be specified using the last 2 parameters, -1 and 1, left to right, top to bottom. So I think 0 is in the center of that, and then left and right is going to be whether it's on the left side of the text box or whether it's on the right side of the text box. So technically, if I made this by 7, we should have a 1 pixel gap on top of the number and a 1 pixel gap below the number. Now, the other thing I want to do is I want to set the screen color. So we'll say screen dot set color, and then in this case, what do I have here? 255, 255, 255. What number is that? Oh, that's right. And then that's just the background color. I think it's green or something. And then we're going to say screen dot draw a rectangle. Okay, like that. Rectangle F, meaning you're going to draw a full rectangle instead of just a box rectangle. And we're going to say 0, 0. So on the, and then we're doing a 3 by 2, so we're 96 by 64. So we can say 96 and we can say 64. Perfect. All right. Then let's change the color of this. Screen dot set color. And let's change that to what I have here, 25500. I don't know what color that is. We'll check. I have all the colors there. Okay, there's no errors. Oh, let's update that. Now it should be giving us one velocity, right? Our velocity X. It should be reading it at 0, 0. So let's spawn that in and see what happens here. And I'm just gonna shoot all the way over to here. There we go. Just like that. And then of course if I turn that on, okay. So we'll go back in there and let's just print the rest of our velocities, and then we're going to do a test launch and see if it works. So we need to do this 3 times. Okay. Oh, let's get that and the color so I can set the color. Now, this is in 1 pixel and it's 7. So this has to be 9. And this one has to be 17 because we're adding 8, right? Our box from top to bottom is 8. We have 1 pixel for the box itself, or 2 pixels, and then we have the text inside, right? So the height of the box is 7. I guess there is no I suppose it doesn't matter actually. If it gives in this case, sorry, in this particular case, because we don't have a border around it, we're not drawing a rectangle F, we're just drawing the actual text box. We can just make it the height of the pixels, honestly. I'm pretty sure we can just do that. Well, we'll see, but I'm pretty sure I can get away with that. All right, so then this is going to be velocity Y, and this is going to be our velocity Z. And then let's change the color of that. So what am I using here? Color. Okay, and then our Z. Let's see, that's color X. Color Y is, I think, blue. So we'll say 0. I have a piece of paper here with the code, if in case you're wondering how I'm like, I honestly don't have this just in my brain. And then I'm not that smart, trust me. And then 0, 0, 255. So this will be 255, 0, and 0. Okay. Perfect. And then that's just the 3 colors, right? Red, green, and blue. X, Y, Z. That's the game colors. So that should be that. We can update that. Now the last thing I want to do is I want to get a linear speed sensor. And I'm going to put it here on top. And then what I'm going to do is I'm going to get a display. And that way we can compare the linear speed to our, get power to there. And then we may as well go, yeah, we can do that. This will be linear speed. And then what we'll do is we'll compare that to our linear speed that we get on the screen. And this is how we're going to be able to check for accuracy. So let's save that. Spawn that in, and this way I can make sure that it works. So, doing a test launch here. Getting there, everything's at 0. And then keypad, we'll just set this to 2. All right, turn that on, and we'll launch. So, let's turn that on to 3. Not giving us any numbers. Oh, I was actually able to go back in here. So why wasn't he giving us any numbers? Let's see. Let's see here. Seven, 8, and 9. It was all zeros. So this is in from our, oh, maybe, did I not connect the composite? I probably didn't connect the panel. I did not. Helps if we connect the panel. Oh, I should have saved that. It's going to auto save. All right. So now this is just our linear speed. So one of these numbers should match up or be close to that. Right? So let's turn this on to 2 again. All right, and then make sure we're going up, and then we'll launch. And then we'll turn that on. 2, 3. 1, 2, 3. It should be our Y. So now it's giving us a number of 243. 243. So that's meters per second. Oh, directional absolute. Oh, cool. I didn't know you could actually change that. So what does this give us? It's meters per second, right? Linear speed, meters per second. How fast you travel. Speed component in one of 4 modes. Modes can be changed in one of 4 modes. 1, 2, 3, 4. Oh, I see. Oh, so maybe I didn't have it set up right. Okay, so let's get our vertical speed. Oh, that's cool. I didn't know you could actually change that. Wow, that's neat. Okay, so vertical would be Y. So what we're going to be comparing this to is our Y speed, which is number 8. It should be that one there. So I'm just hoping that I've done this right. Now let me update this. Let me save it, and let me take a look at the shuttle just so I can. If the shuttle works, I spent a lot of time just trying to. Let me see what I did here with the shuttle. That's cool. Oh, but then I see. I divided it to give me. So same thing, but what I didn't do was. That's a constant number. I don't know why I'm dividing it by 3. Oh, do I have to then divide it distance, traveled? Oh yeah, that's right. So that's where I screwed up. That's where I screwed up. All right. All right. So velocity is your distance divided by time. So all I've done is given us our distance. I haven't actually done anything else. So we'll take this and we'll go to here and we'll see what needs to be done now. So now what I've done, this is our distance. So now what we need to do is we need to divide that distance by the time it took to travel that distance, right? So we are taking our current XYZ, and then what we're doing is we are saving that number. We're waiting 3 seconds, and then we're reading our current XYZ again. And then we're subtracting the larger number, the smaller number from the larger number, which will give us how far we've traveled in the 3 seconds. Then what we need to do is we need to divide that number, that final number, by 3 seconds again, right? So we need to take the, and then it's A divided by 3. So we need to take this number here, which is the distance we traveled, and then we need to divide it by how long it took us to travel, and then we can output that number. Should be right. Hopefully. Hopefully. And like I say, they give us the angular velocity, so they could have handled this inside the astronomy sensor. So I think maybe what I'll do is I'll suggest, instead of complaining about bugs, I think I'll finally put a suggestion on GeoMeta and suggest that they handle this for us. It'll just be so much easier. All right. So tilt switch is on, and then now we're thrusting. And we want the Y velocity, 1, 2, 3, 58. It's a little slow. $83. There we go. You see that? Perfect. Look at that. It now works. Wow, and I don't know how high I was, but I was still able to hop out and come back into there. Okay, cool. So that's that. Basically, that's that. Now, I could have done all this inside the Lua script. But quite frankly, I'm not sure. It'll take me a little bit longer to figure out how to actually make that code. And I don't want to put the timer inside the Lua script because it will cause it will cause a lot of lag in the game. Because anytime you tell the script to wait, it has effects on the code, right? So the game is processing, it's reading all that code, and then all of a sudden it's saying, okay, wait for 3 seconds. And that can kind of throw off the functions, it can throw off a lot of things. So it's better to handle this outside of the Lua script than it is to handle it inside of the Lua script. So there you go. Here, let's get rid of this. All this is just to get our linear speed, X, Y, and Z. So maybe that's why they didn't program it into here. But they really should have a, or maybe, right? Anyways, they really should have something for us. But there you go. If you're wondering how to design to calculate your X, Y, and Z, your linear distance, linear speed, there it is right there. Okay? So what do we want to do now? So now we have our linear speed. Okay? So now what I want to do is I want to be able to write our angle. So here's where it gets kind of complicated. So going back to the whole drawing a circle and trying to interpret velocity and all that sort of stuff. So what we need to do is, do I have it? Do I have that on this one here? Draw a rectangle. I do. Draw a circle. Draw a circle, draw a circle, draw a circle. Okay. So now this is... I want to actually change this. I want to change this because we have 64 pixels for our height. And I want the top 32 pixels to be our rotation. And then I want this to be underneath that. So if I say 32, I could say 35. And that means that this will be 40. And this is going to be 45. All right? So let's just do that. Let's get some. So now we're going to do the drawing of the Euler rotation. Okay, so we need to draw 3 circles. So we're going to say screen dot draw a circle. Now check your spelling, right? Draw is lowercase and circle is uppercase. I don't know, Lua is, it's like, what do they call it? Camel print or something like that. So set color, let's see, draw a circle, and then we want it to be, this one's going to be 16, and our radius is going to be 16. So if we go into help and we say draw circle, right? Screen, draw circle. X and your Y and your radius. So our X is how far in the screen we're going, which is 16 pixels. Our Y is how far down from the top of the screen down to the center is going to be 16 pixels. So 16 by 16, and our radius is going to be 16 pixels from there, right? Our radius, okay? And then what we want to do is we want to draw a line. So we want to say screen dot draw line. Make sure you have a capital line. And this one is going to be 16 by 16. And then we're going to say X and Y. We're going to say X1 and Y1. So let me explain this before I give you the X1 and the Y1. We're drawing a line. We need to draw a line from the starting point to our ending point, okay? Our starting point is the center of this, which I could have a variable. I could say R equals, right? 16 by 16, and then I could just say R or whatever. But in this case, it's just easier to do it that way. So 16 by 16 is our 0, 0, and X1 and Y1 is where we want our line to be. So now we need some variables. We need to figure out how do we get our X1 and how do we get our Y1. All right. So to figure out your position, starting at 0, 0, we need to do some math. We need to do some trigonometry. So we need to use cosine and sine. Okay. So we need to say 16 plus 16, and then we want to multiply that. All right. So we're taking our 16 and that, and then I think this is our radius here. Then we want to multiply that. We want to say math dot cosine in this case, and then we need to add a degree to it, and then we need to say plus Euler rotation. We need to say plus this one here, plus that, or I could say input get number 4, same thing. All right. And then why do we have to add the 1.58 to it? Because it's already giving us our angle, and then we have to add 1 degree to that angle. I don't know why. I tried it without it and it didn't work. So anyway, so you have to add the 1 degree. Right? If you take 360 and you divide it and you do all that, you get this is your 1 degree of 360 degrees. All right? And then we need to add it to this angle, right? I don't know. There's probably an easier way I can explain that. Yeah. But anyways, basically if I'm just Googling it on my phone here so I can explain this in a way that makes sense. But what we need to do is we need to find our angle for X, and we need to find our angle for Y off of 0, 0. So whatever the center of the circle is, we need to say, okay, inside that circle, where is the end point of our line, right? And that's basically what we're doing right now, is we're trying to gauge that. So we're reading our angle, which is telling us where we want our line to turn, and then what we need to do is we need to say, okay, at this point. So let's see. Find x, y. And circle from 0. Yeah, circle xy coordinates. So it says the general equation for a circle is x minus h squared plus y minus. Okay, that's interesting. Where h and k represent the center of the circle. Okay, so 0, 0. R is the radius, and xy form the coordinates for all the points on the circle's perimeter. All right? No. So, yeah, and then we have little diagrams here that you can look at if you want. Basically, we need our angle, and then we need to use sine and cosine. So let's see. Let's look up, so angle, sine for x, okay? And then what we're saying is 4 degrees, right? So what we're saying is, I guess we're kind of getting into quadrants and stuff like that. It gets a little complicated. So let's not go there, because I'm not a math wizard, and there's no way that I'm going to be able to explain this. I'll get trolled to the end of time, I'm sure. Okay, so let's just get our y value, all right, plus 16, all right, and then we want to do the same thing. We want to say math, except this time we're going to use sine, okay, and then we want to say 1.58, and we're going to say plus, and then we're going to use the same thing, euro x, all right. So there we go. So now if we let's see, that should be Nil value, global, euro. Oh, that's this. Whoops, I gotta make this part of that function. So we'll do this. Put that there, and then it shouldn't give me any errors. Yeah, there we go, perfect. All right, so we'll update that. We'll spawn this in, and we should have one red circle with a red line on it. All right. Oops. And we don't. We don't. Why? Why? Oh, because I didn't change the color of it. Whoopsies. So let's go. Let's make it red. All right, update that. Update that. Spawn that in. All right. Oh boy, this is just going to be a quick. What's our runtime? Oh, we're almost at an hour. Okay, perfect. All right, so there you go. So now we have our, and you see it's kind of twitching there. So if we start to rotate, we're tipping over now. All right. For our example, there you see, so it's measuring our rotation. All right, so that's how we measure our rotation and how we print to measure it. Okay, so now what I want to do is I want to do that for a Y, and I want to do that for Z. So just like that. All right, and then let's figure this out. So we're going to need the same thing. And then this is going to be 2. And this will be 3. Right? And then this is going to be 2. And this is going to be 3. Okay? And now what we need to do is we need to change the center of the circle. So this one's 16. This one is going to be 32. And this one is going to be 64. Is that what I have there? 16... circle 48. Oh, and then I have it at 80 actually. So this one here, our X value. What do I have? This one's here is 48. And then this one here is 80. Yeah, perfect. And that's it. That's all we have to do. Oh, and then we have to make sure that we're drawing our line as well. At that point. And then that should be that. That should be that. So if I update that, all right, if I update that and we spawn that in, okay, and then we come over here. No, hold on. Something's wrong here. I didn't change. It's all going here. So this needs to be Y. And this needs to be Z. And then we need to change these numbers here to 48 and 80. So X needs to be 48 and X needs to be 80. Now Y is the same. We're still coming down only 16 pixels, so we don't need to change that, right? So this is how many pixels we're going in, right? We're in 16 pixels, and then this is our radius, right? So I could say R. So here I could add right? I could say R equals 16, and then in this case here I could just do this, right? I could just use that as a variable. It's essentially the same thing. That's the radius there. All right, it's going to the center, and then you're adding the radius. That's all that is. So if you want to change it, you want to make it bigger, that's essentially how you do that. Okay, so if we update this now we should have 3 separate circles with 3 individual lines here. All right. Oop. Yes. Our X, our Y, and our Z. And now we can say, okay, we have our 3 velocities, X, Y, and Z. So let's change the color of the circles so that way we know there's no confusion between what circle am I reading and what number am I reading, okay? So our Y is this here. Which is that, and then our Z is here. All right. We will save this. Like I say, eventually I'm going to build a lander on top of that, which will detach from it, and it's going to come down the line. It's going to be pretty cool. We're gonna try and do a couple of different things, right? So, okay. There we go. Our X and our Y and our Z angles, and now we have our velocity, our velocity that we had to create ourselves, and now that's reading that. So now what we can do is we can continue to add on to this. Like I say, I'm not going to because this is just our test rocket. But I can add another panel here with buttons and another panel with flip switches on it. And that can allow us to save our X, Y, and Z, right? It can allow us to save and chart and do all that kind of stuff. But again, I'm not going to do that in this one. That's pretty much going to do it for now. The next step in all of this is going to be charting this on a graph so we can actually see what our Y trajectory is, our X trajectory is, and our Z trajectory is. That's going to be the next thing, trying to get this into a graph. So I'm probably going to take the rest of the day, I'm going to do it sort of off camera and kind of go through it and configure it, and then that way by then I'll hopefully have the confidence to be able to put out a video and explain that. So yeah, so thank you guys so much for watching, liking, and subscribing. I hope you found this video informative. Let's see, let's just quickly go over what we did. So we took the astronomy sensor and we took our values from it. We have our distances and we have our angle of rotation. And then what we did is we took that angle of rotation and our velocity after calculating our velocity, and we brought that into a Lua script. We then added our code to the Lua script. All right. We then added our code, which allows us to read the data and then print the data onto a screen. By printing the data onto the screen, it allows us to get more of a visual of what's happening to the rocket. Okay? And now the other thing that I'm going to add onto here as well is the fuel, right? So in the next video, that's what we'll go over, is adding the fuel level onto here. And we'll have the fuel reading as a number, but we'll also have the fuel reading as a line. You know, all 3 fuels will come across the bottom, and then as we run out of fuel and pressure, the lines are going to shrink. And that way also we can have that sort of visual like, okay, so where am I in my Earth Moon distance, which is what we'll also cover next as well. Where am I in space, and how much fuel do I have? So then you're able to make real-time decisions about, am I going to make it to the moon or not? Do I need to rotate this way or that way? Blah, 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 blah. Okay? So that's going to be in the next video. We'll go over calibrating fuel and interpreting that data, and then we're going to go over our distance, how to take our distance and converting it from meters into kilometers and all that sort of fun stuff. All right? So yeah, so thank you guys so much for watching, and I will definitely see you in the next one.